Page 7 and 8 of seqs is a series bookwork. We're going to talk about compound interest on this page. So on page 164 reading, we start with $100 and you receive a 10% interest. You receive 10% interest per year. What is your initial amount? Well, this is just like a really easy question, right? The initial amount is $100. The initial amount times the multiplier should give you the amount after 1 year. What is your multiplier? Well, we're going to have $100. We're going to get 10% more, so we should get $110 by the end of the year. What do you multiply times 100 to get 110? You multiply 1.1, which is actually, 110%. So you get 110% of what you had before. How do you find the amount after 5 years? That would be 100 times 1.1, and then you would multiply by 1.1 5 times. So we could express that like that. We can calculate the value of a compounding interest investment using the formula u of n plus 1 equals u1 times r to the n. Okay. Let's see. U1 is the initial investment. R is the growth multiplier, and N is the number of compounding periods. U of N plus 1 equals the amount after N compounding periods. So a compounding period depends on the bank's interest policy. So for example, it could be compounded once a year, it could be compounded once a month, could be compounded every quarter, which would be every 3 months, could be every day. And remember, when we talked about exponents, we talked about compounded instantaneously, compounded constantly. So there's many options. So, but whenever they decide how many months or days or whatever is going to be a compounding period, each compounding period that passes is going to be your n, because you need to multiply the multiplier after each compounding period. Okay, so if you look at this formula, it's a little bit different than the geometric sequence series formula that we had, because the regular formula is u of n equals u1 times r to the n minus 1. It's actually the same thing though if you look at it, because this here you have n plus 1 here and you have n here. Here you have n here and you have n minus 1 here. In the end, it's pretty much the same thing, right? Okay, so let's move on. We're going to fill in this table. And we are going to put n plus 1. So the initial amount would be, the n plus 1 would be 1. And then n plus 1 would be 2 here, 3, 4, and 5. So if we say n plus 1 is 1, what we're actually saying is the initial amount at the beginning of everything. Okay, so that would be after 0 compounding periods. So that's why it's 100 times r to the 0, which is 100 times 1, which is just 100. Okay, so that makes sense, right? The first amount is going to be the initial amount. The second amount is going to be after 1 compounding period, so that would be 100 times r to the first, which is equal to 100 times r, okay, which is equal to, I think if we're using the r of 1.1, then that would be 110, for example, okay? And then the next one is 100 times r squared. And the next one's 100 times r to the third. Next one's 100 times r to the fourth. Okay? Number 1. What will an investment of $3,000 at 10% per annum per year compound interest amount to after 3 years? Okay. So after 3 years. So after 3 years would be this one, right? So it would be U4 equals 3,000, which is the initial amount, times 1.1, actually it's 10%, just the same as our example above. And then here we're going to have the 3. Okay? And so if we multiply that out, we're going to get a certain amount. Let me calculate. It would be 3,000 times 1.331, which is equal to 3,993. And then it says, how much of this is interest? Well, originally we had 3,000, so the amount of interest would be 3,993 minus 3,000, so the interest would be 993. Okay. How much compounding interest is earned by investing 20,000 euros at 12% per annum if the investment is over a 4-year period? Okay, so now we're going to do U5 equals 20,000 euros times the multiplier of 1.12 over a 4-year period. So that'll be 1.12 I think it'll be 31,470. Okay, 31,470. And so how much compound interest is earned? So if they're saying how much compound interest is earned, they want you to subtract out the original amount, which would be 20,000. So you earn 11,470. Okay. What will an investment of 30,000 yen at 10% per annum compound interest amount to after 4 years? How much of this is interest? Okay, so there's two funny things about this. One is that a yen is only worth like a penny, so 30,000 yen is only like $300. And the other funny thing is that in Japan, the interest rate is like much less than 1%, so you would never get 10% interest rate on 30,000 yen. Okay, so let's do U5 equals 30,000. I always see these IB books trying to make everything multicultural, and but whenever they do something about Japan, they always kind of screw it up a little bit. Okay, so it's similar to the one above, right? So let's do this on this calculator. Actually, 1.1 to the fourth gives us something like 1,331. No, it's 1.4641. And then we multiply that times 30,000. We get 43,923. How much of that is interest? Well, we subtract off the original amount, and the amount of interest is 3,923. Okay, that's the answer for B. Okay, next page. How much compound interest is earned by investing $80,000 at 9% if the investment is over a 3-year period? So now we're doing U4. We always put one more than the compounding period. U4 equals 80,000 times 1.09 to the third. 1.09 to the third times 80,000. 103,602. Okay. How much of the compound interest? How much compound interest is earned? So they're asking for the amount of interest, so you need to subtract off the original amount, which is 80,000. You're left with 23,602, for example. Okay. What will an investment of 100,000 yen amount to after 5 years if it earns 8% per annum compounded twice annually? Now they're getting tricky because now they're doing compounded semi-annually, for example. So now, even if they say it's 5 years, it'd be 5 years and compounded twice per year. So how many compounding periods is that? Well, that would be 5 times 2. So the number of compounding period is now 10. Okay, so we're going to have U6 equals 100,000 times 1.08 right? 1.08. And here's another tricky thing. 8% per annum. Since we're compounding twice annually, we have to take that 8% and we have to divide it into 4% for the first 6 months and 4% for the second 6 months. That's the way compounding works. So actually, it's not 1.08, it's 1.04. And then we are going to have 10 compounding periods, right? So actually, it's not U6 either, it's U11 because there are 10 compounding periods, okay? So now we're going to do 1.04 to the 10th power. And then we're going to multiply that times 100,000. And I can just kind of do that in my head, right? So 100,000, that would be 148024. Okay? And they ask for, okay, what's the amount of the investment? So it'll be that. Okay? Compounded twice annually. What will be an investment of 45,000 amount to after 21 months if it earns 7.5% per annum compounded quarterly? Okay, this is getting pretty tricky. Compounded quarterly means that we need to divide the per annum interest rate by 4. So we take 7.5, we divide it by 4, and we get 1.875%. If we want to put that in decimal, we would put 0.01875. And if we wanted to make that into a multiplier, we would put 1.01875, right? So if it was compounded per annum, we would just say the multiplier is 1.075. But since it is divided into quarters, we need to divide the 0.075 in 4, and then we end up with this multiplier. So it would be, let's see, 21 months, and it's compounded quarterly. How many quarters are there in 21 months? There's 7, because 7 periods times 3 months each, because it's a quarter, is 21. Okay, so we're actually going to do 7 compounding periods. So we put U8, original investment of 45,000, and then the multiplier is 1.01875, and then the exponent is going to be the 7th, right? So let's see. 1.01875. 1.01875. And that is the power to the power of 7. And then I multiply that times 45,000. And that would give me 51,249. 51,249. Okay, and let's see. That was the answer. They don't ask us for the interest, so we just leave that. Okay, then you look at example 13. And then they ask, how much money must be invested now if you require $20,000 for a holiday in 4 years' time, and the money can be invested at a fixed rate of 7.5% per annum compounded annually? Okay, so this is kind of asking you the opposite, but let's write out the formula, and then you just need to use algebra. Okay, so we need 20,000. That's not what we start with. We don't know what we start with. So, and let's see, in 4 years' time, and it's compounded annually. So at least they made the compounding part easier, right? So it's going to be U5 equals the initial amount times the R to the 4th power. And this time, we do not know U1, but we do know what we need, which is 20,000. So we put 20,000 in for U5. U1, we leave the variable. And R would be the interest rate plus 1, so 1.075 to the 4th, okay? And then you can see that you could just use algebra and divide 20,000 by this, and then you would get your value for U1. So you want to do your algebra and solve for U1, okay? So we would have 20,000. You can see that you just have 20,000 divided by 1.075 to the 4th. Now go ahead and work that out on your calculator. What initial investment is required to produce a maturing amount of 15,000 pounds in 60 months' time, given a guaranteed fixed interest rate of 5.5% per annum compounded annually? Okay, So now they want everything annually, except for they give you the time in 60 months, just to give you a hard time. 60 months in years is 60 divided by 12, which is 5 years. So the compounding periods would be 5, and so it would be U6 equals U1 times R, which is 1.055, to the fifth power. Okay, and in this case we do not know U1 because it says what initial investment is required. We do know U6, so U6 is going to be 15,000. U1 is going to be unknown for now, and then we have the R factor to the fifth. And so the algebra would have us divide both sides by 1.055 to the fifth, and so that would give us 15,000 divided by 1.055 to the fifth, and then you could just work that out on your calculator. Okay, how much should I invest now to yield 25,000 in 3 years' time if the money can be invested at a fixed rate of 8% per annum compounded quarterly? Okay, now they're making things a little bit more difficult for us. Let's see, 3 years' time compounded quarterly. So how many quarters in 3 years? There's going to be 12, right? 3 times 4. So 12 quarters, which means 12 compounding periods, which means our multiplier is going to be to the 12th. And so our U is going to be U13 is equal to U1, and the R is going to be, let's see, it's 8% compounded quarterly. So that means 2%. The 8% is going to be divided up into 4 quarters. So it's going to be 2% each quarter. So the multiplier is going to be 1.02. And we know that the target value that we want in 3 years' time is 25,000. So we put that in U13. U1 is unknown. So now we just divide both sides by 1.02 to the 12th, and that gives us the answer. 1.02 to the 12th. Okay? And that you can do in your calculator. What initial investment will yield 40,000 yen in 8 years' time if your money can be invested at 9% per annum, compounded monthly? Okay, so 8 years, but compounded monthly. So actually, how many months in 8 years? It would be 96 months. So 96 compounding periods. So our formula is going to be U97 is equal to U1 times the multiplier to the 96th power. And let's see what the multiplier would be. Let's see, 9% per annum compounded monthly. So the 9%, we would divide it up into 12 parts, and so we would end up with 0.75% per month. And so our multiplier would be 1.0075. Now be careful because you might put 1.075, but 1.075 is 7.5%, not 0.75%, right? You need to multiply. You need to move the decimal point 2 times, so it's going to be 0.0075 in decimal, right? And then you add the 1. Okay, so 1.0075, and then to the 96th power. So U1 is going to be equal to U97, which we know, let me write that down here. U97 is 40,000 yen. U1, 1.0075 to the 96th. So U1 is equal to 40,000 divided by 1.0075 to the 96th. And so you can do that on your calculator, right? All right, and that's it.